And I'll hand it over to Hayden. Go ahead, Hayden, you can take it away.
Great. Thank you, Joe. This was a pretty significant severe weather outbreak we had a few weeks ago. It was on a Friday afternoon and evening of May 15th. And Joe, if we want to go to the next slide there. So we're going to take a look at some weather maps and model guidance with this event. And what we normally want to do when we're looking at the potential for severe weather is look at a surface map. That's the easiest way to kind of understand what's happening. Now, the event occurred on the evening of May 15th. This is looking at things at 8 in the morning on Friday. And this is actually a typical setup that you'll see when we're looking at severe weather. You'll see a warm front draped across southern New England. And it's not unusual to have a few showers move through during the morning before the actual severe weather event. That's what we had that morning. Believe it or not, we actually had that this morning with a very significant severe weather event that occurred to our southwest in the Philadelphia, New Jersey area. And in this case, the severe weather was just further southwest, but it's the same dynamics. You usually get like a warm front to move through in the morning. And if we go to the next slide, Joe, we'll look at what things look like in the afternoon. So what happens is the warm front lifts off and you get that increasing moisture, a kind of a more sticky feel, an increase in humidity. And if you've been outside today, you've definitely noticed the difference between what we had the last couple days and this afternoon. Definitely a little more stickiness to the air out there. Now, if things had moved a little quicker today, we certainly would have seen severe weather up here. Fortunately, we were spared that. One of the things that we tend to look at, there's a lot of different model guidance that we use to build a forecast. And in this case, it's kind of like a view of several models put together, and they indicate where the greatest risk for severe weather is. And for the case on May 15th, it was indicating that northern Massachusetts, especially into New Hampshire and New York State, we're going to experience the greatest risk for that. Now, this just gives you an idea of where it's going to happen. There's a lot of different moving parts that come into play in actual assessing the severe weather threat for an entire area. So this is just one piece to the puzzle there. And I am now going to turn it over to Frank, who's going to kind of get into the meat and potatoes of how we go about utilizing different model data to assess the threat for severe weather.
Yeah, thanks, Hayden. So this map that we're looking at right now is verification for the event. So all these blue circles indicate where severe winds were observed. And you could see that cluster, Joe, if you just want to use your cursor there and point up north of Albany around the Saratoga Springs area. Many reports of strong to severe winds. So the graphic that Hayden was showing you on the previous slide, the HREF and the SHREF did a really good job showing you the probability, the highest probabilities of strong storms, severe wind would be in the greater Albany area and north of there into Saratoga. However, you can see there's a lot of blue dots farther to the south and to the east. Even in Boston, there's about 5 blue dots there, indicating we had 5 individual reports of severe wind. If we remember from the previous slide, the model was indicating almost 0 probability of strong winds that far to the east. And even to the south in Connecticut, we had 2 reports in northwest Connecticut there of strong winds, and even in the lower Hudson Valley. And the model there was indicating almost 0 probability of severe winds. But like Hayden said, there's a lot of moving parts. And, you know, forecasting, as we know, is not that simple. You just can't look at one parameter and, you know, say this is what's going to happen. So let's take a look at why the convection maybe sustained itself farther east than what the model was indicated, at least in that one graphic. So on the next slide, we're taking a look here at the 700 millibar heights and winds. So this is roughly what the weather, the wind flow looks like at about 10,000 feet above the surface. So the contours here are the height of the 700 millibar surface, and the wind barbs follow those heights pretty closely. And you can kind of see how the wind flow there, it's kind of counterclockwise. We say it's like cyclonic flow. Whenever you have that counterclockwise type of flow, that's in supportive of upward vertical motion. That's what you have in the base of the trough and even the head of the trough. So here we're looking at pretty favorable conditions for upward vertical motion. And even more importantly, the image there with the greens and the yellows, those are the wind speeds within the trough. So at about 10,000 feet above the surface, those yellows, we have about 50 to 55 knots of wind. That's a lot of wind at that level, even for middle of May. So we had a lot of wind to work with. So just that amount of wind at that level is going to tell you that those storms are going to be racing off to the east, and that's going to increase the threat of strong to severe winds just by how strong the winds are aloft. So what we concluded is that the strength of the trough, the cyclonic curvature, and having that much wind field aloft was able to take that squall line and hold it together and maintain its intensity farther to the east than what the models indicated, and thus, severe weather as far east as Boston and as far south into Connecticut and the lower Hudson Valley. On the next slide here, we're looking at one of the models, the HRR, simulated reflectivity. So this is showing you where the model thinks storms are going to be. One of the dilemmas with this forecast was some of the guidance, especially some of the high-res guidance, the HRR was indicating that we could potentially have 2 rounds of thunderstorms, one in the late afternoon and then another one in the evening. And that's what this model is indicating here. You can see the squall line farther to the west across New York State, then into Pennsylvania, but also some thunderstorms out ahead of the main line. We call that like prefrontal thunderstorms. So the HRR and some other models were indicating we would have 2 rounds of convection, 2 rounds of thunderstorms, and that did not take place, as we know. So why did we not get that initial late afternoon round of convection? Well, if we look on the next slide, looking back at the event, this is the HREF, one of the forecast models, the high resolution ensemble forecast. The top left panel, we're looking at 500 millibar heights and winds, and in the lower left is the 700 millibar heights and winds, which is 10,000 feet. 500 millibars is about 18,000 feet, and then the top right is the 850 millibar heights and winds, roughly about 5,000 feet above the surface. And then the lower right is the MU Cape, which is the most unstable cape, which is really giving an indication of where the most buoyant air mass is. And those colors there are showing you that the most unstable, the most buoyant atmosphere is still well to the west of New England, across New York State and Pennsylvania. Now, all 4 of these maps are centered on 2 p.m. that afternoon. So one thing I wanted to point out to you, and Joe, if you could help me, the contours of the 500 millibar heights, even 700 and 850, you can see kind of like a ridge axis over New England. So a little bit of a bump there. That's where the heights are highest. That's a ridge axis, and in the ridge axis, that's where you have downward vertical motion and you kind of have a capped environment. So it's really hard for thunderstorms to develop in the ridge axis in a capped environment. So it turns out that the models were about 3 to 6 hours too slow with the trough and with the cold front approaching the area. It came in a little bit later than what the models had earlier anticipated. So we had that ridge and that cap over us in the afternoon, and that prevented thunderstorms from developing or actually having those 2 rounds of convection. We only had the 1 round, which was with the squall line later in the evening. And on the next slide, we'll look at the dew points. And the models, these are the observed dew points. Most of the model guidance was showing you that by 23Z, which is what this chart image here, that the highest dew point air would be over southern New England by 7 p.m. And you can see that the higher dew points, the mid-60 dew points, are still to the west across New York State. Here in southern New England, where our dew points are just getting into the upper 50s and lower 60s. So everything was delayed by 3 to 6 hours, and that kind of prevented having 2 rounds of convection. And it also prevented the severe weather from getting even further south and east, like into Rhode Island and southeast Mass. If it came in a little bit sooner, closer to peak heating, and especially before sunset, the convection most likely would have been able to make it farther to the south and east into Rhode Island and southeast Mass. So I think the next section we're going to talk about messaging, and I believe Ronnie is going to be taking over that section.
Yeah, thank you, Frank. So one of the agencies, one of the NOAA agencies that we work closely with during this kind of severe outbreak events is the Storm Prediction Center. For those of you who are not familiar with the SPC, they are located in Norman, Oklahoma, and basically they will issue outlooks up to 8 days in advance, but especially more details in the first 3 days. So, and this is the outlook map going back to 3 days prior to the outbreak event, and you can see they have so on the left picture, it's you see there's a marginal risk for Western Mass and Connecticut into New York State and Pennsylvania, and for those of you who are not familiar with the categorical outlook legend, marginal is kind of like the level 1 of 5, and then the next level up is slight risk. So you can see the day 2 morning update, they introduce a slight risk, so that's an upgrade from the previous day. So they are more confident in a more significant severe outbreak. And then by the afternoon, there's an enhanced risk. That's level 3 of 5. That's relatively rare for southern New England. So that's definitely caught people's attention. And then 1 day before, they expanded the enhanced risk to include much of the Hudson Valley and even into Vermont and New Hampshire. And this is a graphic that we sent out on social media, kind of explaining, kind of zooming into the area so you can see the cities better. And then on the left, we highlighted a threat. The main threat would be damaging wind gusts above 60 miles per hour, large hail above a quarter size, and frequent lightning, and cannot rule out an isolated tornado or two. And we kind of refined the time period to between 3 to 10 p.m. and we kind of encourage people to please monitor the weather and have plans to seek shelter if severe weather were to threaten your area. And this is looking at so when the SPC issued the outlook, the outlook we showed you earlier, that's the kind of overall outlook. So the enhanced risk would be based on 3 parameters: the risk for tornadoes, risk for severe wind above 60 miles per hour, and the risk for large hail above a quarter size. And in this case, you can see that the tornado risk, it's not insignificant. It's 5% area, but you can see the wind was much higher, up to 30% probability. So that was actually the main reason why the SPC issued an enhanced risk for our area. And this graphic, and we did send out this graphic on social media. This, just kind of explain to you the 5 levels. And, usually we are more familiar with marginal or slight risk, but enhanced risk was introduced for that day. So that means numerous severe storms are possible. A few could become very intense and could be a few tornadoes, a lot of wind damage as expected, and some large hail is also possible. And this graphic is it's part of the mesoscale discussion that the SPC issues. And earlier I told you how we collaborate closely with SPC, and it's not just in the days leading up to the event, but also during the event as well. And we work closely with our neighbors. And in this case, this would be affecting the Erie, Pennsylvania office and Buffalo, New York office, and a lot of times these storms, they start off from the west and then they migrate to the east. So it's very important that we monitor the storms as they blossom, and there's a lot of collaboration going on behind the scenes to coordinate headlines and just make sure that people are given enough time to take precautionary action for the storms when they finally arrive in our area. And this is around 2 p.m. Central Time, so 3 p.m. Eastern Time. You can see this graphic shows a warm front lifting north, and that, when you see this kind of setup, there's really a lot of low-level moisture in the atmosphere, and then coupled with daytime heating, that kind of can lead to explosive development of severe storms. And in this scenario, there was a line of severe thunderstorms with damaging wind as the primary hazard. But because it was such a volatile environment, you cannot rule out a few tornadoes, and that's why us and the neighboring offices will be coordinated with SPC to issue a tornado watch. And this is 5 p.m. Eastern Time. SPC, based on the developments, issued kind of like highlighted an area that has a elevated chance for tornadoes. And sure enough, actually, that there was one confirmed tornado in Albany's area that afternoon, and so that's. But the main threat would still be the damaging wind gusts. This is just a look at on the right-hand side, you can see the area of the tornado watch, and on SPC website, it would kind of also go into detail what are the different level of risk for the different hazards. In this case, the severe wind is the highest threat, followed by severe hail and tornadoes. And 7 p.m. Eastern Time, this is finally moving into our area. And at that time, the squall lines just about to move into western Massachusetts. And this graphic just shows you that kind of communicate to us that the threat continues, and expect damaging winds in the next couple of hours with a threat of a tornado or two. This is 9 p.m. Eastern Time. Same thing, the line of severe thunderstorms continue to cross our area, but it's expected to decrease in intensity in the upcoming hour as it moves closer to eastern Massachusetts and Rhode Island, as the conditions become less favorable for the sustenance of the severe thunderstorm. This is a graphic that we put out on social media showing the extent of the tornado watch that was first initially issued. And a few tornadoes possible, but again, main thing was the severe wind, up to 70 miles per hour likely. And at 7:30 p.m., the tornado watch was expanded to include Hartford and the northern Connecticut counties as the threat evolved, and we continue to collaborate with our neighbors, in this case Albany and also SPC, to continue to refine the headlines so people can be adequately warned. And an hour later, we included the Boston and Providence metro areas in the warning zone, in the watch zone, and you can see we took out the headlines for the western Massachusetts counties. one of the main things, working social media that day was to kind of highlight to the public the difference between a watch and a warning. A watch generally represents, the atmosphere is favorable for tornadoes, and it's time to kind of be prepared and have contingency plans if conditions were to go south. A tornado warning is either we have a radar confirmed tornado or we have a confirmed tornado on the ground. It could be by law enforcement, by storm spotters, or members of the public. And when a warning is issued, you just have to take shelter immediately because it is a life-threatening situation. And as for tornado safety, the steps to take are a little different depending on what kind of house you live in. The mobile home, people who live in mobile homes are at the greatest risk because mobile homes are not a safe shelter for tornadoes. So if you were to live in a mobile home, you would have to find alternative shelter ahead of time. And in the event of a tornado warning, you should be able to move to that alternative shelter quickly. And now I'm going to pass it on to Bill to talk about what happened.
All right, thank you, Rodney. All right, so as many folks probably remember, one of the things that made this event really tricky was that the Boston radar was down for an upgrade. So these next two images are showing just the radar progression, the progression of storms that were going through our area using Albany's radar. Now, this is just an example of what one of the tools that our forecasters use to help put up these warnings, the Albany radar being one of the locations we looked at. On top of that, in these kind of scenarios, we're also looking at other offices' radars, like the one in Brookhaven, New York, the radar that's in Weymouth, for the airport radar, and then even there's some university radars that are in the Massachusetts area that we were using as well to put out warnings. But one of the biggest things that helped us out in this situation was having the ground reports, because the big thing is the radar can only see so high up. So looking at these radar images on the left-hand side is just the typical radar that you would see with its reflectivity, and you can see storms progressing from New York into western Massachusetts, Connecticut, and then eventually into central Massachusetts. And then on the right-hand side, what we've got is the radar velocity images, which are basically showing the radar's estimate of the wind speeds that are coming, that are happening within the storms going through. And then if we go to the next slide, we'll see that there's the radar images going through central Massachusetts into eastern Massachusetts, and then also into Rhode Island. And then one thing I didn't point out on the previous one, the yellow boxes are showing the severe thunderstorm warnings that we put out. And then there's teal boxes that you can see at the very end. That would be like when we're putting out warnings for the mariners. And you can also see to the north, there's the tornado warning that the Gray Maine office issued. But you can just kind of see the progression of storms going through. And then the reason that these boxes were as wide as they were is these storms are moving really quickly, and again, the big thing is that we had lots of ground reports that were reporting wind damage in a really timely fashion, which is in any event, even when our radar is up, that information isn't valuable to us. And so if we can continue on here. Now, another thing that we look at, besides reports that come in from different folks, we also have a lot of automated systems that can give us not only reports of tree damage or give us specific values of wind speed versus having tree damage or anything like that. And then this is just showing the maximum wind speeds that we had across southern New England and into western or into eastern New York. as of 10 p.m. on Friday, on the 15th. And as you can see, the highest wind gust that we had was the 63-mile-per-hour wind in Worcester. And then again, a lot of other areas still seeing pretty high wind gusts, anywhere from the mid 40s to the low 60s, depending on the location. So then if you want to go to the next slide, Joe. And then this is an image. If you go to the Storm Prediction Center's webpage, you can actually take a look at all the wind, all the reports of severe weather that's happened across the country. And so as you can see across the Northeast and then also into New York, just lots of wind speed reports. And then there's also reports across the Southern Plains. But again, the big focus was on what was going on up here. But if you're interested in ever seeing those storm reports of what's happened on a particular day, the Storm Prediction Center is the place to go. So then if you want to go to the next slide, Joe. So here's we're taking a look at during the event to kind of get an idea of what's where there's damage that's happening. We do take a look at power outage maps from time to time. And then this is just a screenshot that we took. As you can see, there's a lot of damage, or at least power outage that's concentrated in the Worcester area. And then the other area that was another portion that we saw was in northern Middlesex County. And then this is the image that Frank had showed earlier, just showing all the wind reports, various wind reports that we got. And again, these reports are always invaluable. If you've ever see any kind of damage or anything like that, don't always assume someone has said it. Definitely get that information, and it's really, really helpful to us in the office. And then these next couple slides here, we're just going to look at some of the what happened on the ground, some images of the different damage that happened across our forecast area. As you can see here, there's damage to a roof building in Holyoke, Mass, and this is from the Holyoke Fire Department. And you can just see in both of the photos here what that damage. Some more damage photos on the left-hand side is the in Holden, Mass. You can see that there was a tree that fell onto. I'm not sure if I think that's a shed, maybe a house. Not real positive, but still significant damage there. On the right-hand side, there's a tree that's fallen on a house in Westward, Mass. And also there was an 86-mile-per-hour gust that was an unofficial report that we had from a nearby home weather station. So really. You can see the extent of the damage caused by that wind. And then on the next couple of slides coming up here, we're going to be looking at some damage in the Pepperell, Massachusetts area. Some of the images on here are showing just some tree damage, some scattered tree damage that had occurred. But on the right-hand side, you can see kind of an overview map where there's these sporadic parts of wind damage in the purple, but there's a pretty concentrated area of wind damage in the yellow that's being highlighted by Joe there. And this is on Brookline Street near Cheyenne Road, which is what we're showing here. This is kind of zooming in on one of the areas that we took a look at some wind damage. So here's an image from one of the emergency managers in Pepperell. On Brookline Street. Here's the immediate aftermath of, you can see all these trees that are down, some trees that are uprooted. And of course, this is during the evening. And as we'll see in a second here, there's some more photos during the morning. So the day after the event, it's always easier to see things, of course, when the sunlight's out there. But as you can see, just lots of tree damage, lots of snap trees. Some trees knocked over and pushed down. And again, you could just see all these different photos with just showing various degrees of the tree damage. And then here, because we kind of highlighted the Brookline and Cheyenne Road area, this is just some more tree damage photos in some different locations. Again, you could see trees falling on houses, totaling cars or trucks, and so this is just from the wind that had gone through the area, and even seeing some uprooted trees. But again, a lot of damage from the winds here, with trees falling into houses and and just various degrees of the trees falling down and whatnot. But we can keep going here. We got some more. Here's a timeline. So that emergency manager, we work pretty closely with these folks. And so he kind of gave us a timeline of what happened in Pepperell, the area that he works closely with or works in. And at 8:15 is kind of when we saw they had a heavy and sudden rain with strong winds, but there was no hail. And by 8:20, the power was out, and that was confirmed to the emergency manager by the National Grid text. And so, as you can see, just in that 5-minute time frame, that's how quickly these storms can cause a lot of damage. Now, as time goes on, people kind of see what's going on. By 8:22, that was when the first call was made to the police and fire for the wires and trees, or wires down, and I'm sure trees down as well. And then again, 8:31, multiple trees and poles knocked down. By 8:41, National Grid was on the scene to try to figure out how to estimate or how to restore power. And then by 9 o'clock, they closed Brookline Street, which we had seen before on the previous images, all that wind damage and all those trees that were knocked down. And the street was opened up a couple hours later after they were able to clear some of that debris. So here's a drone shot of some of the straight line wind damage that occurred in Groton, Mass, towards the end of Cow Pond. And one thing to kind of note when you're looking at this image here, you can kind of see that all these trees are kind of pushed just straight down. They're kind of spreading out a bit, and they're not kind of converging in on a location. The trees are just spread out, fanning out with the wind that was going through. And then if you want to go to the next, here's another image, a closer image from a drone to the straight line wind damage in Groton. And again, you can still kind of see the trees are kind of spreading out in when the winds have gone through the area. So one thing we do get questions on these kind of situations a lot is, well, there's tree damage, there's lots of damage, it's got to be a tornado. Well, one thing that we do as an office and at all the Weather Service offices is if there is a suspected tornado, we do have folks that go out and take a look at we go out for storm surveys is what we call them, and we take a look at what the damage is. Now, just because even if there's a significant amount of damage, that doesn't necessarily determine that it is a tornado. It's not on the amount of damage, it's the pattern of the damage. So as you can see in this photo here with these trees, they're kind of converging together, and you kind of tend to see that when you have a tornado that's happening versus with a more of a straight line winds or stronger wind events or even microbursts. You see things kind of spreading out, not really converging in on a location. And then this, like I said, this kind of goes through all the different things that we look at. But you can see that there's a difference between straight line wind damage and a microburst versus a tornado damage. Now you can get the same amount of damage from a tornado from some of these stronger wind events as well. I mean, it's regardless of if it's a tornado warning or severe thunderstorm warning, folks should prepare, because you could have damage like we'd seen in the Groton area and in some cases. Now here's taking a look at the Cow Pond Road. That was kind of close to this is where the drone was looking. As you can see, sometimes we try to go into these different areas to see what's happening on the ground with the wind damage. And as you can see in this situation, it's a little tough to get through this roadway because all the trees that were blocking the road. And then we also had some damage in as well in Lowell. Here's a tree that was pushed over onto a house. And I think with that, that's all we had, unless folks had any questions or if Joe or any other guys had to add anything else to the presentation.
Yeah, okay. Thanks, Bill. So we certainly welcome your feedback. As I mentioned, this is our first try at going through an event review. We hope to do more of these. So we really would like your feedback. You can either email me at the address below or to our webmaster. Either way, we would appreciate your feedback. If you have any ideas for other things we can do on webinars besides these event reviews, we're certainly open to that. In the meantime, if you want to ask questions through the chat, we can go through and answer some of these. Okay, so going through these, let's see, a lot of people asking about sound. I know we had an issue earlier. Okay, so we have a question from John. Maybe Hayden or Frank, I'll throw this to you. Did the absence of prefrontal storms contribute to the strength of the squall line?
Yeah, I can take that, Joe. So it can work both ways. If we had just some isolated storms out ahead of the main activity, it probably wouldn't have been, a significant impact. If we had had, numerous thunderstorms, then it would have probably impacted the amount of heating during the afternoon and limited the severe thunderstorm threat. And also, sometimes that can actually press the thunderstorms further south than what's expected, because these thunderstorms tend to gravitate towards what we call higher instability, and the warmer the temperature gets, it's going to be more favorable. So a few cells wouldn't have impacted it greatly, but if we had had a lot, then it could have made it more of an impact.
Okay, thanks, Hayden. Next question is from Josh. It is interesting how the models were off on the timing of the trough. Is it normal to have this large a timing issue when you're only 24 hours out? And maybe Frank, I'll throw that one to you.
Yeah, I think initially the models got better as we got closer to the event with the timing. And I think that's, typical 24 hours or beyond, especially with these convective events. That there's some margin for error, but I'm pretty sure as we got closer to the event, it looked like it was going to be a little bit later of an event. So I don't know if Hayden, if you have anything to add to that.
No, I agree, Frank. I think when we're talking with winter storms, the models tend to have a better handle on the timing, especially as we get inside, say, 36 hours from the event. With thunderstorms, there's so many what we call small-scale processes that can impact that. For example, today's severe weather event in the Philadelphia area was well forecast, although it ended up coming 3 to 6 hours earlier than some data suggested. So subtle differences on timing, sometimes several hours, which obviously is significant, for public events or planning, is a challenge with thunderstorms, where when we're talking about winter events, it's usually easier to nail the timing down, say with an hour or two, say in a winter event.
Okay, we have next question is from Robert. Please discuss the microburst environment that occurred in the Merrimack Valley. Hayden or Frank, you want to handle that, or would you like me to take it?
I mean, I can take it. I think a big factor in the microburst environment was the wind fields that Frank had talked about. The wind fields that say way above an elevation 20 to 30,000 feet off the ground. Usually that becomes a significant player in these type of events. So if you have a line of thunderstorms and there's what we call small scale processes, that's why when microbursts are very localized, one area can have like 90-mile-an-hour winds, and then as you see like a half mile away, there's just 50-mile-an-hour winds, if that. So the key in these cases often is the strong winds, say like airplane flight level, and if the environment is right, they can be brought down by the thunderstorm over very small localized areas.
Charleston north of me continues to have strong storms. Often storms will develop or grow stronger after they pass me east near Franklin. Does the Blackstone Valley play a part in?
Joe, I think we're having some audio issues again.
Okay, can you guys hear me?
I can hear you now.
Okay, sounds like I might have cut out. We're doing this for folks out there. We're doing this partially from the office and for other folks at home, so please bear with us. So I'll read it again. It's someone from Blackstone, Dion. He said the storms tend to die out near the Uxbridge area, while in Milford, Holliston to the north continues to have strong storms. Often storms will develop or grow stronger after they pass me east near Franklin. So he wants to know, does the Blackstone Valley play a part in the weakening? Aiden, that maybe is a good one for you.
Yeah, in terms of it, that's a difficult question. The valley and terrain definitely plays an impact on thunderstorm development. There's actually been some study with inside the Connecticut Valley, the way the wind's set up. There's actually can be an increased a tornado risk at times due to the winds shifting around in the valley area. There's a lot of micro scale climate things that may impact that. It'd be hard for me to answer, a specific location. I know growing up, it always seemed like the thunderstorms would miss me, be, here or there. Some of that is because usually when you get a thunderstorm, the area in general around it is it's very localized where the most significant damage is. And then outside that, a lot of times, it's a tree down here, a tree down there. I mean, there's cases differ. So sometimes that can be perception too. But yeah, there are a lot of these small scale climate impacts that we're probably not aware of. But that's something hopefully in the future that as the weather models get better and we continue to learn more, that we'll be able to diagnose.
Okay, thanks, Aiden.
Sure.
A couple of shorter questions, maybe I can just answer them. One is from Tony. Can you define a microburst? Sure, that's just a localized downdraft from the thunderstorm in an area less than or equal to about 2.5 miles. So think of a microburst as you take a glass of water, pour it on a table, and the water will spread out kind of in all directions. It's the same thing, but we're just talking about wind. So it's just the downrush of air essentially from a thunderstorm. Next question from Joe. If discrete cells got going, would the tornado threat have been higher? And actually, yes. If you remember that one model forecast of showing the storm out ahead of the line, that was an environment that was pretty favorable for tornadoes. And in fact, we were actually concerned that morning that if we had storms pop up ahead of the line, we would have had a much greater tornado threat. So fortunately, that was not the case. Go through some more questions. How are you guys able to issue warnings with the radar down? I can answer that one pretty quickly. As Bill mentioned, we had surrounding radars available. We mostly relied on the Albany radar because it had kind of the best view. We also used the radar on Long Island that had a decent view of the area. Also, there's a radar out in the University of Massachusetts in Amherst, so we have access to that online. We use that. Also, the FAA has a weather radar in South Weymouth, just south of Logan Airport. That gives us good coverage of eastern Massachusetts and Rhode Island. So we can kind of use a bunch of different radars. We typically do that even when the Taunton radar is operational, just to give us different views of the weather across the region. Let's see, from Michael, does the NWS issue text advisories for severe weather that would show up on a cell phone? So right now, through the FCC, warnings for tornadoes and flash floods are going to a system called wireless emergency alerts. So you'll get those on your cell phones. Right now, they're working on expanding that to severe thunderstorms, but it will be for the higher level severe thunderstorms, kind of like what moved through Philadelphia today, when winds get higher than, say, 70 miles per hour, 80 miles per hour. So that will be coming, I believe, within the next year. That capability will be coming to get those alerts. Let's see, from Hank, could you show that slide again? That was the place to go for looking at recent severe storms. I believe that was a Storm Prediction Center. So that is just spc.noaa.gov. Or you can just Google Storm Prediction Center. That will be the place.
And then you'll want to click on Storm Reports.
Right. Thanks, Aiden.
Sure.
Let's see, one from Nathan. Questions on warning decisions. On TBOS, which is at the FAA South Weymouth radar, I recall there were what appeared to be strong rotation couplets near Pepperell and again west of Lowell. Is there anything related to the terminal Doppler velocity that led us to not issue a tornado warning? Was that based on the history of the damage being straight line, or am I misreading something? Aiden, that might be a good one for you.
Yeah, you know, there's usually a combination of things. That is a factor. If there isn't a history of tornadoes, if the history is mainly straight line, but it doesn't. That's not the only thing. There's a lot more that goes into play, and it is viewing the number one thing as is obviously reports, but without that, it's viewing the radar. Most of the signatures we saw indicated more of a straight line wind threat. We didn't necessarily have consistent what we call gate to gate shear. It was more winds going towards the radar or away from the radar, and that usually is an indication of more straight line wind damage. Hopefully that makes sense.
Okay. Yep. Thanks, Aiden. From Chris, hello. I'm a spotter. Called in 2 hail reports of pea-sized and then marble-sized hail. Do these hail reports help form the picture of what is going on? I'll say absolutely. You know, we have a lot of information we look at based on the radar, satellite, but it's really the ground truth from the spotters that really help tell the picture of what's going on. So certainly, you know, call them into us. You can send them to us on social media, Twitter or Facebook. Those are really, really helpful. So we certainly encourage people reporting. And we're running out of time, but we'll try and get to a few more. Let's see, Hank was asking, is there an opportunity to replay the webinar? Yes, this is being recorded. It'll be on our YouTube channel within the next day or two. And let's see. Quick one from Brady, maybe Hayden, you can answer this. What caused the weakening to happen just past Worcester? The airport reported a 63-mile-an-hour gust. I live 67 miles southeast and only got 35-mile-an-hour gusts.
Sure. Yeah. So it was a combination of things. As you remember, it was getting later into the evening, so you lose that heating from the day, which fuels the thunderstorms. There was a little bit of a marine influence from the southwest winds coming off the relatively cold ocean. So that was a fact. Those two things were the biggest factors in that.
Okay, and we're running short on time. Just a couple more questions. Band Age 11. Welcome. Who gets to press the button for the weather alerts? And it's just the person who is working the radar. Typically during severe weather, we have two of our meteorologists who are monitoring the radar and issuing the warnings. So it's usually just one of them. On this particular day, I believe it was Hayden and one of our other meteorologists, Andrew. And then a little later into the event, Bill and I actually were issuing some of the warnings. And also, I'm seeing a few questions on reliable anemometers one can buy for private use. Being the government, we can't recommend or endorse any types of weather stations, but what we typically tell people is to do a Google search. You'll find a few companies come up. You can read some of the reviews and probably make a good selection from there. So sorry we can't help anymore with that, but we are the government. So with that, we're going to wrap up this webinar. It's about 6 o'clock. I want to thank everybody for joining tonight. Again, this was our first shot at doing these, and we hope you enjoyed it. Again, we appreciate feedback. You can email me at my email address there. If you have any recommendations for future webinars. Just a reminder, we have a webinar scheduled tomorrow for 5 o'clock. And this one will go over the flooding that occurred on Nantucket and Martha's Vineyard on May 23rd. So feel free to join us for that. Otherwise, have a good evening. Take care, and we will talk to you all soon.
Great. Thanks, everyone.